M.S. Ramaiah University of Applied Sciences.
Hi students, let us discuss the measurement of the height of a given specimen and dividing it into equal divisions. The aim of this experiment is to measure the height of a given specimen and dividing it into equal number of divisions by using a scriber. A vernier height gauge is a measuring instrument similar to a vernier caliper, which is used to measure the height of a given specimen and marking over them. It has a special base block which is finely lapped and have attachments which are used to measure the height of a specimen and marking them. In this experiment, the range of the vernier height gauge used is 300 mm and its least count is 0.02 mm. It should be noted that the main scale of the height gauge has been graduated in centimeter. So, the maximum reading which will be seen on the main scale of the height gauge is 30 centimeter. Figure shows a typical vernier height gauge and its parts. It basically comprises of a main scale, a fine adjustment screw, fine adjustment scale locking screw, a vernier scale setting screw, mounting base block, a scriber locking clamp, main scale adjustment screw and a lock nut for the main scale adjustment screw. The apparatus required for conducting this experiment comprises of a vernier height gauge, a scriber locking clamp, specimen to be measured, surface table and magnetic V block. Procedure for carrying out this experiment. Firstly, attach the scriber to the vernier height gauge using the scriber locking clamp. Bring the tip of the scriber just in contact with the plane of the surface table using the vernier scale setting screw. Check for the zero error of the height gauge at this point. Zero error is checked by verifying whether the zero of the main scale is exactly coinciding with the zero of the vernier scale. If the zeros on the main scale and vernier scale are not coinciding, use the main scale adjustment screw for ensuring the zero error of the height gauge. For measuring the height of the given specimen, mount the specimen vertically on a magnetic V block and turn on the magnetic field of the V block using the knob provided on it. During mounting, it should be ensured that the specimen is exactly perpendicular to the plane of the surface table and the bottom face is perfectly resting on the plane of the surface table. Now, slide the vernier scale up and place the scriber over the specimen such that the tip of the scriber is in contact with the top surface of the specimen. Note down the reading from the height gauge. This reading is the height of the specimen being measured. Figure shows the height of a sample specimen being read using a vernier height gauge. Here, the main scale reading is taken by considering the reading from the main scale which coincides with the zero of the vernier scale. In this case, the reading is 199 mm. The decimal level reading of the height of the specimen is read by considering the vernier scale reading which is exactly coinciding with its corresponding division on the main scale. In this case, it is the second division after 80 mm which makes the decimal value 0.84 since the least count of the instrument is 0.02 mm. Therefore, the height of the specimen is read from the height gauge as 199.84 mm. The height gauge is also used for marking a given specimen. This is done by using the scriber. Firstly, divide the total height of the specimen into the required number of parts into which the specimen has to be divided. In the example shown, If the specimen has to be divided into 4 equal parts, then divide 199.84 by 4, which gives 49.96 mm. Adjust the obtained reading after division in the height gauge using the vernier scale adjustment screw and the fine adjustment screw. Scribble a line on the face of the specimen to the adjusted dimension by moving the height gauge along the y-axis of the plane of the surface table when the sharp tip of the scriber is in contact with the plane of the specimen, which will result in a line being drawn on the plane of the specimen. Similarly, draw the required number of lines on the plane of the specimen to divide the specimen into the required number of divisions by adjusting the height gauge value to the multiples of the divided value so that the specimen can have equally divided parts. There are different ways of scribbing a specimen. It can either be scribed as only horizontal lines, only vertical lines, or a combination of both horizontal and vertical lines. The readings obtained must be tabulated in the format of a tabular column. Carry out the calculations using the standard formulae and find the dimension to which the specimen needs to be divided into the given number of parts. This experiment has its limitations. With a least count of 0.02 mm, the height gauge might not be able to produce very accurate readings. If a complex shaped specimen is marked, it might consume a long time and also may lead to minor errors in marking. This concludes the experiment calibration of a pressure gauge using deadweight's pressure gauge tester.
Hello students, today we are going to carry out the experiment measurement of a height of a specimen using a vernier height gauge. The aim of this experiment is to measure the height of a given specimen using a vernier height gauge and divide it into a given number of parts. The apparatus required for carrying out this experiment is a vernier height gauge. The vernier height gauge consists of a finely lapped base, a main scale, the vernier scale, the vernier scale locking screws, the fine adjustment screw, the main scale locking screws. The least count of this height gauge is 0.02 mm. A magnetic V-block. This is the workpiece whose height is going to be measured, and it is going to be measured by clamping it on the magnetic V-block. The V-block consists of a knob over here which turns on or off the magnetic field. A scriber. The scriber is used to measure the height of the specimen and also divide it into a given number of parts. A scriber clamp. The scriber clamp is used to assemble the scriber onto the height gauge and lock it using this clamp. Now let us start the experiment. Initially, take the scriber clamp and fit it in this position. Ensure that the scriber clamp has its screw completely unlocked to accommodate the scriber into the lock. Fit the scriber inside the scriber lock in such a way that the scriber completely fits into the groove, and tighten the screw of the scriber clamp. Before starting the measurement, we have to ensure that the vernier's height gauge is reading 0. For that purpose, we have to first unscrew the vernier scale locks and make sure that the tip of the scriber touches the surface table. Now you can see that the 0 on the vernier scale is not coinciding with the 0 on the main scale. These two need to coincide with each other for getting an accurate measurement. The 0 on the vernier scale and the main scale can be coincide together by operating the main scale adjustment screw. This adjustment screw is locked using the locking screw present over the adjustment screw. Before adjusting the main scale reading, you need to unlock the locking screw and then adjust the reading in the main scale. Once the instrument has been set for 0 reading, lock the main scale adjustment screw using the locking screw. Now we are ready to carry out the measurement of the height of the specimen using the vernier height gauge. You need to mount the specimen vertically such that the height of the specimen can be measured. For this purpose, we will be using the magnetic V-block. Place the magnetic V-block vertically. Clamp the workpiece in between the two flat surfaces in such a way that the specimen is in contact with the surface table. Now, clamp the workpiece onto the magnetic V-block by turning on the magnetic field from off position. For measuring the height of the specimen, we need to make sure that the tip of the scriber is in contact with the top surface of the specimen. Unlock the vernier scale screws and slide the vernier scale over the main scale until the tip of the scriber comes in contact with the top surface of the specimen. Now you can see that the tip of the scriber is exactly in contact with the top surface of the specimen. At this point, lock the vernier scale screws. Now we have to take the reading by first checking the position of 0 on the vernier scale with respect to the main scale. We can see that 0 on the vernier scale is coinciding just above 16 centimeter on the main scale, which can be taken as 160 millimeter. Next, we have to check the vernier scale and the main scale divisions, which are exactly coinciding with each other. When we observe, you can see that the third division after 7 on the vernier scale is coinciding exactly with the division on the main scale. Thus, the reading of the height of the specimen is 160 mm plus 0.76, which is 160.76 mm. Now we have to divide the specimen into equal number of parts. Suppose we want to divide the specimen into 3 equal parts, which means we have to divide the total height of the specimen by 3. The height of the specimen, as we all know, is 160.76 mm. This, when we divide by 3, we get 53.58 mm. So now we have to set the reading on the vernier height gauge to 53.58 mm using the vernier scale locking screws and the fine adjustment screw. Set the vernier scale with respect to the main scale for approximately getting 53.5 and then set 53.58 mm using the fine adjustment screw. Now we can see that the vernier height gauge is reading 53 mm plus 0.58 mm. Now the vernier height gauge is set to 53.58 mm. So mark a line of 53.58 mm on the workpiece using the scriber. Bring the scriber in contact with the surface of the workpiece and slide the height gauge gently over the surface of the workpiece. Now we have marked the first line on the specimen, but since we want to divide the specimen into 3 equal parts, we need to mark one more line which measures 53.58 mm above 53.58 mm, which accounts to 107.17 mm. Repeat the same procedure to set the vernier height gauge to 107.17 mm and scribe the second line over the specimen. Now we can see that the second line has also been scribed on the specimen and the specimen has been divided into 3 equal parts. This concludes the experiment, the measurement of the height of the specimen using a vernier height gauge.
At MSR UAS, we spark your imagination unlike any other.